Hey, hi everyone. I hope everyone is doing well. Really enjoying the videos that I have been preparing with a lot of research. So today, basically, we are going to take we were going to talk about the different database types. Essentially, I think it's good to have an understanding of what are the different kind of databases, and it also helps to understand where those would be useful and in what scenarios a certain type of database is useful, right? So let's start off, I think, the discussion with our standard relational databases. So relational databases have been around for a very long time. There's usually used to store data in form of rows and columns in a table. Rows are called tuples and columns are called attributes. Uh, Usually, you have a unique key that is used to access a particular row, right? A row will have, let's say, 10 columns, right? You want to access a row, and you are storing, let's say, 1,000 rows worth of data. You want to access row number 31, right? For example. So you will access that through a unique key, which is called a primary key. That primary key is used to identify the row, right? The same primary key, for example, can also be present in another table, but then it is referring to this, let's say, the table, first table, primary key. Um, and when you have the same primary key being referred to in another table, it's called a foreign key. All right, we can get into the details of it, but just try to see like what are the concepts and what are the terms associated with each of these database types. There's also an important concept related to referential integrity. So when a primary key in a database table, right, appears in another table, as I had mentioned, it appears at the foreign key, and then that relationship is a valid relationship. That is what is called as referential integrity. Uh, Relational databases definitely follow, your acidic properties, and some of the examples are MySQL Server, Microsoft SQL Server, and Oracle, right? Relational databases are, I would say, to some extent difficult to scale beyond a point, uh, which is why I think you would find that there are other kind of databases that are more, let's say, suited to if you are looking at massive, humongous amount of data, right? So, which brings me to the next kind of databases, which are usually called the NoSQL databases, and these can basically store values in variety of ways. We have like around four types of NoSQL databases: the key value database, and MongoDB is a very good example of that. Uh, let's say you have a key which is again similar to what you have in relational database as your primary key, right? You need to identify what are the attributes associated with, right? So in this case you have a key, let's say, whatever, 231 234, and then you have a set of values, right? This value can basically have multiple, let's say, equivalent of attributes, right? You have name, you have gender. So if you try to draw similarities, a key is nothing but your primary kind of a key. Values are nothing but your kind of columns only, right? Just so that you understand. Although there is no direct like relationship, between relational and NoSQL databases, but that is how I am trying to draw parallels so that you remember it, right? Document oriented, again, MongoDB is a prime example. Data can be stored in form of field values like in JSON and XML and BSON as well, boson as well, right? A straightforward example, like, I mean, if you were to look at it, you're storing, I think, let's say, ID, a value, and then you have the different attributes, right? Or let's say different values, right? You have your first name, you have email, you have cell phone, and maybe let's say you're looking at what a customer, what that person basically likes, right? So this is how it is stored. The structure is definitely not just limited to this particular kind. You can have n number of attributes, like you can have first name, last name, You can have email, you can have cell phone number, you can have address, you can have likes, you can also have places visited, etc., etc., right? You get the idea. Correct. Then coming on to the next data type inside NoSQL databases is the Graph DB. Neo4j is a classic example. They've been around for long, and they usually look at, when you talk about graph databases, it's going to have a node and edges structure. A lot of the social media sites, right, would actually use graph databases because it's easy to traverse graph to, understand what are the relations. So, for example, if you have, let's say, a group, right, on Instagram, that group might be connected to, let's say, 1,000 followers, right? So all those followers basically, then become kind of a graph, are linked through a graph database, right? The nodes and edges basically define the relation, right? Then you also have wide column databases. This is most primarily like Apache, Cassandra, SkylarDB, Apache HBase. What happens is that columns are not same for every row in this. So let's say, for example, you have real-time analytics data. You have time series data. You have IoT log data. Correct. So when you're looking at a wide column database, you are actually looking at data that is going to vary uh, for a row. So in one instance, for example, if you're looking at, let's say, the time series data, right, in one instance you might get 10 columns worth of data. Then in another instance you might get only 2 columns worth of data. Now those columns could be anything, right? I mean, your columns could be, for example, time series. Classic example would be your weather data, right? So in your weather data, you might want to see humidity levels. You might want to see, like if you're storing it, right, you might want to see latitude, longitude, wind speed. You might want to also see temperatures, right, minimum, maximum, whatever, right? Then you might want to see pollution levels, right? So when you're storing that data, right, you might not get for every instance, right? So let's say you log the data at 11 a.m., then you log the data at 12 p.m., then you log the data at 1 p.m. In some cases, for example, you might not get the values, right, across, let's say, those 8 or 10 columns that we just described, right? So when you don't get the value, doesn't mean that you're not going to store the value. You're still going to store the value, right? So that's what it means by saying that columns are not same for every row, right? Now, coming to, I think, distributed data. Uh, Distributed data basically came into existence wherein, your, let's say, business use case would be that you want to not rely only on a central location, right, for your data. So because it kind of increases the risk when there is a central database failure. Correct. So central databases, for example, might make a lot of sense in, let's say, a school or a university environment, or let's say a warehouse environment, right, where you're just single warehouse, where you're like, looking at all the items, and let's say a library, right, in a university. In those cases, I did, it makes sense. But what if you're like operating a business in a city also, right? For example, you might have like 5 or 6 distribution centers. You might want to store data across the different distribution centers, right? You're not going to store the data only on one instance, increasing the risk, right? So you're basically storing data across multiple machine servers or instances, as opposed to, right, a single machine. Advantages are, obviously, you are reducing the risk of failure, you're increasing the resilience. Scalability is definitely improved because you can just replicate a particular instance. For example, you have 5 instances, let's say, running in a city. One of the instances basically needs to be, uh, let's say, scaled. Or let's say in a particular locality you are seeing more orders coming in, right? Let's say this is an order management system, so you're going to release, basically just increase the capacity or increase the storage of that particular location, right? You're not going to spend on all the 5 locations, right? So that's the advantage of distributed database. Performance definitely improved because whatever relevant data you need from a particular location, you're going to fetch only that data. Improved availability, less latency. It is like very easy to like fetch, like the data that is relevant, right? Your availability, obviously, remember, I think those we always measure availability in terms of those nines, right? Triple nine, four, five nines, four nines, whatever it is, right? So availability of data improves because it's partitioned, right? And you can deploy the instances of your distributed database across public clouds, for example, AWS, GCP, and Azure, or you can do an on-premise solution as well, wherein you kind of look at some hybrid approach. So on-prem, for example, could be a database is set up on your company's whatever, right? Premise, right? Some part of the data, for example, might also reside in the public cloud service. So it's both like a private as well as a public mix, and that is called a hybrid cloud environment. A hybrid database, that is residing both on-prem as well as on the this thing on cloud. I think some of the other types of database that you can read about, cloud databases, we just touched upon it, right? AWS, GCP, Azure. Uh, Object-oriented database, not used much. I haven't come across, but hierarchy-based database, again, if you looking to store, let's say, if you're looking to store data across different hierarchies, right, and each hierarchy has some relationship, right, then you can consider looking at hierarchy based databases. But if you were to go and research about, I think, databases, I would probably put NoSQL databases as the topmost category, where you should definitely go and read about documentation of MongoDB, Neo4j without, without a doubt. I think, how do you get like well versed with these databases? I think you need to understand that companies are going to invest in these databases based purely on their use case and the kind of business problems they are solving. So, for example, Facebook is going to definitely look into Graph DB. They're not going to spend a lot on relational databases. Similarly, right? I mean, if there is an IoT company, right, that's collecting, let's say, weather data, right, or they're collecting sensor data, right, they are not going to spend a lot of money on, let's say, key value databases, right? So understand, I think, what is the business use case, and then based on that, try to understand what kind of databases would be useful. So that's it for now. Until next time, stay well. Please subscribe to my channel, and hope the learning continues. Bye.